Good morning, everyone. Good morning, everyone online. So my name is Patrick Healy. I'm product manager for AKS. I work for George. My focus specifically is networking and network integrations. So basically east-west and north-south networking. Anything talking pod to pod, anything talking in or out. But today I am doing, this is echoing apparently. Today I'm doing troubleshooting. So this is focused for both devs and cluster admins, where things that you can do from a cluster perspective. So this isn't necessarily how do I use tools to debug my app in Kubernetes, but how do I debug what my app is doing in Kubernetes and why my cluster might not be working or my app might not be working the way I'd expect. Okay, anyway, so a couple very common problems that we see support tickets come in for. We see questions online. I get these from customers. Applications that are crashing. Why are they crashing? Often it's an out-of-memory kill. Sometimes it's node resource contention issues. Sometimes it's node resource exhaustion issues. Sometimes it's traffic doesn't work. So we'll go through and we'll hit all of these in order and just talk about the common causes and why things are happening. So basically, going in, application crashes, that's an app thing. It's not usually a cluster thing. You can look at your pod logs. Going in, looking at kubecontrol logs, obviously probably everyone who's used Kubernetes has done that at a time before. One neat trick that some people don't know is that kubecontrol logs has a -p argument, which will show you the previous incarnation of a container log. So if you have a pod that is doing a crash loop backoff, that will get you the ones from the last crash. That will go in and often give you some very good information about what's going on. When you are seeing an out-of-memory kill, it's often memory. Obviously, it's in the name. But in terms of resource limits, it's usually not a problem with CPU because pods can't exceed a CPU limit. If you hit your CPU limit, you just don't go higher. You can't get any more. At least in the current state, although I believe this is starting to change with some of the support coming in C Group v2, if you exceed the memory limit, the pod will get killed. And sometimes that will be an kill, and you'll see the process will actually go into a state. It'll show in kubecontrol described pod that it was killed. Sometimes it just kills a child process in that pod. And so you have no clear indication except in the pod logs of why that happens. Give you a quick example. I was working with an application that was spinning up 5 threads for some static analysis testing. And when they put the app in Kubernetes, it took 10 times longer to run. And it turned out that they had not allocated enough memory, so when the pod would get up and be running 5 tests in that one pod, it would always kill the last thread. And so their tests had a retry rate of something like 50 to 60% by the time it was able to get through all of them. Another common issue that can happen if you see your pods moving around is if you're consuming too many resources on a single node. So a lot of times that'll happen if you don't have your resources and your limits set appropriately or don't have them set at all, which is very common. Those are what Kubernetes uses to determine where and how many pods can be placed onto an indicated node. So if I have a node that has 4 cores and I have pods that have requesting a core each, I'm only going to put 3 of those on that node because there's some set aside for the system. If I don't have any resources on there, I might put 10 pods on that node, and then they will all run into CPU contention and perform poorly. With memory utilization and disk I/O utilization, you can start getting into disk pressure and memory pressure, where Kubernetes will actually start evicting pods off the node and restarting them on other nodes, moving things around. And that looks like a random app restart if you don't go look at the logs and see why. So in there, I did put 4 things down at the bottom. Like I said, make sure you have the appropriate limits set. Sometimes you need to look at using larger nodes. If your pods are consuming 3 CPUs each and you have 4 CPU VM SKUs, then you're only getting 1 pod per node. That's not very efficient. You've got a lot of white space there. You might want to go to a 16 SKU or 16 CPU SKU so that you can get multiple pods per node and have a lot more utilization. Sometimes it's useful to use anti-affinity rules if you have pods that are heavy hitters on disk I/O or memory, where you don't necessarily need to keep them apart architecturally, but you know that you have 2 applications that both do a lot of disk I/O. it can be worth using anti-affinity rules to keep them separate so that you're not overloading any one node. And then finally, if you have apps that need it, especially if they're using special hardware like GPUs, but occasionally if they're just really intense workloads, you may need to just put them in a dedicated node pool and use node selectors for that. When you're going in to look at your pods, common things we'll see in clusters where we get a ticket that the app's not working right is we go in and look and there's just a bunch of pods in crash loop back off, or there have hundreds of restarts. I think my current record on a single cluster I've seen was a pod deployment that had 13 million restarts that no one had ever addressed or dealt with. And it was because it had a resource limit of 1 gig and a JVM that was set to have a 2 gig heap. So obviously, as soon as the app got going, it would over-allocate its memory and get restarted. And they wanted to know why the performance was bad. It was a pretty obvious one when we pointed it out. Sometimes you'll see the kill in a crash loop backoff. Like I said, that's what happens when you have a pod that has a process. That process gets killed, that gets reported up to Kubernetes. That is, typically respected or reflected in the pod status. If you have a multi-process pod, which is what the bottom one is demoing, where I've got a Python pod with 4 workers in it, in this case, I had 2 of my threads get killed, but the pod itself did not get killed. The pod itself did not ever actually show any change in status up in Kubernetes. So in this case, when I was running load tests against this pod, probably 40% of my requests were taking 5 or 10 seconds to complete because they were hitting a thread that was getting killed, and then the client would retry and get a thread that hadn't been killed yet. Either way, it's a manifestation of an kill, but it's not immediately obvious why. When you're seeing pods that are having issues like this, that are consuming additional memory and causing problems, it's very important to utilize multiple node pools. Without that, if you have a pod that is overutilizing memory or overutilizing disk I/O and starting to cause things to move around and shift on the cluster, that can impact other workloads on that node. That's bad enough when that's another piece of your application or another completely separate application. It's worse if you're not separating your system in user pools and now that workload that's being impacted is core DNS. And that can escalate a single app issue into a cluster outage if you have enough shifting and churn to basically take the DNS services for the entire cluster offline. So addressing that, separate your system pools and user pools. You don't necessarily need to have more than one of each unless you have a business need for it or an application need for it, but at least have a separate system pool and a separate user pool, and taint the system pool so that user pods do not end up on there. Keep that dedicated for your system workloads and things will run much smoother. Going through, like I said, resources and limits, always have your resources and limits. If you don't have them, the scheduler can't make any intelligent decisions about what to do with that workload. So it just will put it wherever it thinks it has the room, whether or not it actually does. And you want to be very careful with memory because, as I said, you can't over allocate your memory without getting a pod restart. It doesn't just cap you, your pod gets killed. Let's see. Sorry. This is a very common one that I get. Why did my app crash when I upgraded my cluster? Hopefully people are aware of this, but I have seen a lot of people aren't, that when you look at your deployment and you see your strategy and you say max unavailable 1. So I have 3 pods, I can only ever have 1 unavailable at a time. Why did my app crash during the upgrade? That deployment strategy field only applies to updates to the deployment. So if I update the image, if I update the configuration, that does a rolling restart, that will do that rolling restart such that I only ever have 1 unavailable pod. It does not apply to disruption events in the cluster, which can include virtual machines getting hardware failures or network failures. It can include cluster upgrade events. It can include cluster scaling events, anything that causes a change in the cluster state. If you don't have a pod disruption budget configured for your application, as far as Kubernetes is concerned, it can shut down all the pods at once if it needs to move things around. So having those there, having that object in place to let the cluster scheduler make the intelligent decisions it needs to about what your app can tolerate is very important. Let's see. If you are finding that your application is having trouble and all of the pods on a single node are unresponsive, and this especially happens with things that are disk I/O intensive, something to be aware of is that your container root file system and any empty directories that you may have in there, those are all backed by the root disk of the node. And that root disk in any cloud platform is going to have a certain amount of performance that it's allowed, both usually in megabytes per second and in IOPS. And exceeding either of those will throttle the entire node and will start to impact all of the workloads on that node. When you're doing the math on this and thinking about it, it's important to be aware that there's both maximums for the VM type and maximums for the disk, and you're typically bound by the lower of whichever applies. So if I have a VM SKU that can handle 8,000 IOPS, but I have a 2 gig disk on it that can only handle 120, then I'm capped at 120, not 8,000. That is a lot less common of a problem in newer clusters, and when I say newer, I mean in the last 2 years-ish. AKS now has full support for ephemeral OS disk, which basically means we will put the OS disk in local temp storage on the node rather than backing it with a managed disk out in Azure Storage. That's great if, because nodes are ephemeral. They're supposed to be able to just go away and get restarted. That's the way Kubernetes is entirely built. And the ephemeral cache storage space has significantly higher performance than network-backed storage in Azure Storage. So as long as that's available and has enough space, we will use it. So typically on any of the bigger, higher performance SKUs, that's going to be available, that's going to be used unless you've resized your OS disk to be larger than it can take. Additionally, we have bumped the OS disk size to be larger so that you get a bigger disk, which gives you more I/O throughput. If you're seeing issues with I/O throttling, typically the best solution is to make sure you're using ephemeral OS disks. Make sure you're using a SKU that supports it. Make sure that you have a disk size that fits inside the available cache space on that node. If you can't use it because the SKU you're using doesn't support it, or you need a larger disk than you could reasonably support in ephemeral OS disks, at least make sure you're using a SKU with premium disk support. If you are using a standard D4 V4, you have no caching, you have no premium disk, you're attached to basically a standard hard disk drive. You don't have a lot of throughput there, and multi-node or multi-pod workloads where you have a lot of things writing to the disk at once will overwhelm those queues pretty quickly. And if you are still having problems with all that, you can increase the size of your OS disk to raise that I/O cap that I mentioned earlier. I'm not going to hit this whole slide. It'll be available for reference later, but basically in newer SKUs, you want ones that say at least D, because that will give, in the second half of the name, that's the signifier for it to be disk full, which means it has that temporary cache disk that you can use for ephemeral OS disk. And if it has the S, that means it supports premium storage. So out of the 4 down at the bottom, the standard D4 DS V4 is the most capable in terms of not having any I/O throttling. If you are seeing I/O throttling, I'll show you a couple different ways to diagnose it, one now, one a bit later. The simplest way is to look in the portal at the VMSS metrics. You can look at the disk queue depth. If that is sitting anywhere in multiple digit numbers especially, you probably have too much disk I/O on that node. So you can see here I have 3 nodes and 2 of them are at less than half an IOP and the other one is sitting at 170. That node was basically unresponsive. It fell off the network. Kubelet eventually stopped updating the lease and it got rebooted. But because the workload that was on there was still configured to consume that I/O, it was just running a load generator to demo this, Kubernetes just put that onto another node, and that node crashed, and it moved it to another node, and that node crashed. So it could just keep cascading back and forth in your cluster if you have a misbehaving workload. All right. Let's see. Other common things we get, this one especially to me because networking. I'm setting up a service and my service traffic doesn't work. Why doesn't my service work? Couple different things that can be going on. First off, if you have your service selector having the wrong labels. So if it doesn't actually map to any pods, obviously there's no destinations, nothing in the back end for the load balancer, traffic's not going to go anywhere. Second, if the port that is being targeted in the container is not the appropriate port. This is a very common one with lift and shift apps that you're trying to containerize the first time around, where maybe it's a Tomcat app that is configured to listen on 9080 instead of 8080, and you didn't catch that. So when you created the service definition, you pointed it at 80 or 8080 or 8443, whatever it happens to be. If it's not the right port in the container, obviously the traffic is not going to go anywhere, and you will see a service that looks like it's down. The other common thing is probes that aren't set appropriately. So Kubernetes will not send traffic to a pod that is not considered ready, but it will send traffic to a dead pod if that pod is showing as ready. So if you don't have your probes set up appropriately such that the pod is considered both live and ready, it's not going to get destination traffic, and you won't have any valid backends, or potentially you'll have invalid backends. The difference there is that a liveness probe is used to control whether the pod is completely crashed. So a pod that is failing its liveness probe will be restarted. A pod that is live but not ready will be kept running but not sent traffic. So you can get into problems where if you don't have your probe set appropriately, all of your pods go non-ready but are still alive. They'll just sit there in that state. Kubernetes won't do anything to recover it. So you need to make sure that your probes are appropriate in both cases. You want to use readiness probes to deal with transient failures, liveness probes to deal with permanent failures, or things that should trigger an app restart to get recovered quickly. Relatively recently, in the last 18 months, I think, startup probes were added. Those are nice for apps that take a long time to start up. Back to that Tomcat app I mentioned. You can delay the start of the liveness and readiness probes until the app is fully online so that you don't have the other common problem with this, which is an app that takes a long time to start up and the liveness probe reboots it before it finishes starting. Going in and looking at it, describing the service object is always a very useful thing to troubleshoot this. You get a lot of very relevant information on this screen. Important things down here is it does give you the target port, so you can see that this service is targeting a port 5000. If that's not what the pod's running, traffic's not going to go. And down in the endpoints list, you can see how many different IP address and port combinations are currently valid destinations. So in this case, there's 3 up there, there's 9 more. I have 12 pods in the cluster. That tells me that, hey, all of my pods are online and all of them are valid destinations. Going into the other common network configuration problem, and that is snap port exhaustion. This one is a little complicated on the technical side to get into, but basically the way the Azure Load Balancer works by default, every AKS cluster gets assigned a single outbound IP. And that outbound IP gets partitioned into a set of ports that are available to each node to use for outbound SNAT connections. Now, when I make an outbound connection from a pod that's running on a node, I can reuse the same SNAT port unless I'm connecting to the same destination IP and port. So if I have an app that makes 10 connections to the same database because it's doing connection pooling, that's going to consume 10 SNAT ports. In the default configuration, where you only have a single IP and you're not coding the number of ports explicitly, the number of ports you get per node is specified by that chart over there. So that can cause a little bit of unexpected behavior in that when the nodes count in the cluster goes up, the number of SNAT ports that's available actually goes down. And so I have seen people have trouble where they scaled their cluster up, it reduced the number of SNAT ports, and then that caused an issue. So there's a couple different options for this. The simplest and the least change in the app or in the cluster is typically just to add more resources, add more pods, and spread them out across more nodes so that you have more SNAT ports available. That's usually the quick fix to recover an actual outage, get away from the problem, and get time to do the more permanent solution. The better answer is to use Managed NAT Gateway. It's a significantly newer egress networking technology that's available. It's fully supported in AKS. And it doesn't bucket the ports per IP like standard load balancer does, so you don't run into that issue. Now, as long as I can have a single IP, and as long as I don't have more than 64,000 simultaneous connections to the same IP and port out of my cluster, I'm not going to have an issue. If you do have more than that, you add more IPs. It's pretty easy. And then the third option, if you don't want to make changes and don't want to use managed NAT, is you can use the options that are available in our documentation to manually specify the number of snap ports that are used per node and the number of IPs that are available. And there's a little formula that's down in the corner where once you figure out how many simultaneous connections you need, you can just use that formula from the docs, and it'll tell you exactly how many IPs you need. So if I wanted to run 4,000 ports and I had 40 nodes, I'm not going to try to do the math live, I'll get it wrong, but it would give me a number. So all that covered how you can detect things manually and live and common problems that you've seen. But when you're coming into a cluster that's not working and you don't know why and you're not sure, there's a number of useful tools that are available outside of the standard Kubernetes APIs to help you find the problem. First thing I want to point out is the cluster diagnostic settings. So this is something that is not enabled by default, but can be configured manually on the cluster object via Azure policy, via your ARM templates, a number of different ways to do it. And this configures the storage of certain logs out of the cluster control plane, so out of those managed components that George was talking about that we run. So this is where you can get access to your API server log. This is where you can enable and store your audit logging, and you can see why did this deployment get changed? Who changed it? That's in the audit log. That's the only place that information is. If you don't have this configured, you don't have a way to go back and see what account changed it and where they changed it from. If you want to look at why Autoscaler made the decisions it did, or why Scheduler moved a workload around and made this placement that it did, this is where you get this information. Once you have this configured, you can dump this out to any of the standard Azure Diagnostic Solutions storage locations. So you can store it to a storage account, you can stream it to an event hub, you can put it to log analytics, or you can put it into a partner solution. Most people that I've worked with either have a partner solution or will put it into log analytics for easy analysis. Storage accounts are great for archiving for things like your audit logs, but you may not want to send your API server logs there just because it'll be harder to look at them. Azure Container Insights is an add-on that's available in AKS. It's supported by the Azure Monitor team. And they also have some more functionality coming that Justin will be talking about later this afternoon. So I'll leave that for him around managed Prometheus. But in any case, this is a solution that goes in and pulls state data, logs, metrics, and everything for the individual workloads in your cluster rather than the cluster nodes itself. So in this particular case, those 3 pods that I showed earlier that were in crash loop backoff, you can see they're right here. They have 3 restarts. They're in a status of warning and if I clicked on them, it would pop up a little window on the right side, show me that they are in crash loop backoff. I could look at the logs. That that trend line that's there, I don't have a screenshot to show it, but there's a very common stair-step pattern that you'll see when you have, back to the earlier case of pods that are having a thread killed, but not the entire pod. You'll see 20, 40, 60, 80, 100, 20, 40, 60, 80, 100. It just repeats over and over because the pod grows in memory usage and then a thread gets killed, it's back down, and it starts over again. That kind of stair-step pattern is a very obvious indicator that there's something going wrong with memory utilization. And then, of course, Container Insights also does have the ability to pull out your pod logs, scrape Prometheus metrics, and pull out any of the historical data and retain it in Azure. There is a support tool that we use a lot when SRs come in, when support requests come in, called Periscope. It's built into Azure CLI as AKS collect with a K. Periscope, it dumps a point-in-time snapshot of your cluster, and it dumps it into a storage account. It's not sending it straight to us. It dumps it into a storage account you control, so you can use this outside of support cases if you want. It goes in and it pulls a bunch of the node status information. It pulls a bunch of configuration information. It runs some status checks and connectivity checks, validates networking configuration. By default, it only includes the cluster services, but you can pass it command line arguments to have it pull in anything you want. and it will dump out also all of the cluster objects and everything. So it provides a very good snapshot to let someone see what the state of a cluster is at a single point in time without having to give them any form of access to it. It's very useful if you need to provide something up to support for us to see it, or just to a vendor, third party, whatever. You can say, snap my cluster, snap this namespace and the nodes that are associated with it, and it will provide them the information they need to be able to look at it. Just a quick display of, this is a view in the output directory of Periscope for a single node. So you can see the kind of stuff that's there. It has API server checks. It has checks to reach ACR, containerd information, internet check, IP tables rules, pretty much everything that support would find useful for troubleshooting what's going on in that node. One of my favorite tools to use is Inspector Gadget. This is a tool that was originally written by a company called Kinvolk from Germany. They've been acquired by Microsoft, so they're part of the family now. And Inspector Gadget uses eBPF add-ons, which are little programs that you can compile and load into a running kernel in order to report data out or modify packets, do things like that. It's the same kind of technology that Cilium is using to do incredibly efficient packet filtering and monitoring. Inspector Gadget is using it to do all sorts of live observability on your cluster that you wouldn't normally have, with something that you can temporarily deploy and then undeploy when you're done. So just to give some examples of things that's going on here that you can do. If we're in that situation where you have a workload that is thrashing your disk I/O and you don't know why, top block I/O runs on a namespace or across the entire cluster, and it'll come up and it'll show you what pods, what processes, what nodes and namespaces are doing your top I/O talkers in a cluster. So in this case, you can see I've got FIO, which is just a load testing software running in a pod to simulate it. And it's sitting out there and doing an entire 42 IOs. But that's actually enough that this node was being crashed because I deliberately provisioned the smallest node that you can in Azure and get to join to AKS in order to demonstrate the problem. It didn't have any premium disk, no ephemeral OS storage, basically worst case. Next one down, Gadget Top TCP, shows where your network traffic is going. If you're seeing a lot of cluster egress and you don't know where and why, here's the pod, here's where it's talking to, and here's how much data it's sending and receiving. All of these work like KubeControl Top, where it's a constantly refreshing list. In your pane, you just leave it up and running, and it'll show you whatever the state is at any point in time. Top File does exactly the same thing, but for file I/O. So if you're trying to see who's accessing what, it's a great way to do it. Moving on, there's a trace component. This gets into watching syscalls. So in this case, the two that are up there, I'm doing a trace SNI, so it will actually see for outbound TLS connections or inbound, who's talking, who are they talking to, and what is the host name that they're connecting to. Not just the IP address, it's not watching the DNS here, it's actually inspecting the TLS header in the client hello as it goes past to get that data out. Next one down is trace network. This is just doing that same kind of trace, but it's doing it at the protocol stack. So it does it at TCP, UDP, SCTP, what have you. Obviously, you're not getting the TLS data, but you get much more generic data because you're not looking into a specific layer. And you can see it does do some resolving there. So down here, the third line from the bottom, you can see there, oh, that's a 53 or a port 53, it's DNS, and it's talking to kube system, kube DNS service. So instead of giving you the IP, it knows it's a service name, it just tells you what it was. Going into trace, back to that, why is my pod having issues? Because a thread is being restarted. Gadget trace kill shows you across the entire cluster or the entire namespace exactly what threads are being killed off by the out-of-memory killer in the kernel and where they're running, what pod they're in, and everything that's going on, how many pages they had reserved when they did it. So this is the easiest way I know of to monitor for a problem like that across the entire cluster without having to log into every node and look and see what's going on. Trace exec and trace bind, these are useful for figuring out why or what is happening in a pod. So back to that lift and shift I mentioned earlier, where you're picking up an existing application, you're trying to put it in Kubernetes, you're trying to figure out what's going on, why isn't it working? So I can run trace exec and I can see what process is being started when I start this container. So for these two, I started these commands and then I deleted the pod to restart it. And this is the output I got. Anybody want to take a guess why that pod isn't getting acceptable service traffic? No? Okay. So in this case, that pod is only listening on localhost. So you can see down there in the lower right corner, the bind address is 127.0.0.1. So service traffic can't talk to that port because it's not being exposed outside the pod. If it was, you'd typically see 0.0.0.0. This is also really useful if you're trying to do dual stack clusters. If you put a workload in and it's not accessible via IPv6, well, it needs to be bound to both 0.0.0.0, which is the IPv4 any address, and it also needs to be bound to :/0, which is the IPv6 equivalent. If you don't see both of those lines here when that pod starts up, then it's not binding to the IPv6 protocol stack, and you're not going to have any ability to accept traffic there. All right, I think I am at time, and that is the last thing I wanted to hit. Do have a nice little QR code to our roadmap, which is up on GitHub. We have our status updates up there. We tend to keep things pretty open and announce when things are in development, when they're happening. And there's also a cloud native GBB office hours that I always like to mention that runs usually every other week. It's just an open team session that's available to the public. You can come on, you can ask questions, there's presentations, demos, all sorts of neat stuff. Any questions before I get kicked off? Mm-hmm.
Where can I find the description of gadgets?
Yeah, so back a couple slides when I first mentioned Inspector Gadget, there's a link to the homepage. There's a very good documentation section in there that says, here's all the various different commands you can run and what they will show you. So, and if you just search for Inspector Gadget with a K, it's easy to find if you don't have access to the slides. Anybody else?
Yes, you will get access to all the slides after today.